Good morning, everyone. My name is Ami, and I'm a master's student at Aalto University. So we are holding this thesis research in collaboration with PwC about 5G and MEC security aspects. So the research is held at Kumikor by the Professor Jose Costa and Petri Mahonen from the Department of Information and Communications Engineering. Before talking about the security aspects of MEC platform, we need first to introduce the 5G architecture. What about 5G is making possible to have a MEC component in the structure and in the network level. The 5G architecture is a disruptive technology kind of, because network functions are using APIs to communicate between each other. And in that, there are HTTPS protocols, TLS, and other requirements to follow to make that possible to exchange users' information inside the core network. And for the 5GC, we have network functions, different network functions, one for a dedicated use. And one of them is the NEF, the network exposure function, that is communicating to another network function, which is the AF, an application function used by external parties. By external parties, I mean the cloud service providers, the application providers, and any kind of party that would like to have access to capabilities from the core network or to provide services to end users. And in that, we have the MEC platform. For the MEC, it's a special host and also the system level management platform, the architecture that interacts with the NEF as an entry point to the core network. And through that, we have security guidelines from the 3GPP specifications to follow about 5G and how the communications is made possible to avoid any attack at the network level, for example, and to make sure that a secure communication is happening in the network. About the security guidelines from the 3GPP specifications, we have this KPIF, which is the Common API Framework, that state about all security aspects to be followed by the mobile operator and also by the third party to have access to data analytics from the core network or to give services to the end users. Among those requirements, we have TLS as a protocol to make a secure communication. We have access tokens, we have OAuth tokens. All those requirements are to provide confidentiality, replay, and integrity protection at the network level of the communication between the mobile operator and that third party. But then when we look deeper into the implementation of 5G and different APIs provided by the MEC, what are in the APIs or in the actual implementation that makes possible to use user data to hack them or to track the users, especially when it goes about this location tracking that we introduced earlier. Why is it possible using these APIs? That's what we will look deeper in the following sections. Now let's look at the implementation of this attack scenario of UE location tracking. So there are 4 main points that we need to look at. How is the MEC or the service provider getting those information from the core network? What is the core network or the mobile operator doing to make sure that the security guidelines are followed? How is it processing those information, and what's actually in the content of those information that makes it possible to send back the data analytics of the UE? And fourth, what between the specification and the implementation, where is the gap? So first, the MEC would send this request to subscribe for analytics exposure, meaning that I send my informations to the NEF and I tell them, okay, these are my security credentials. These are the access tokens, and I am a trusted application function. Now I request the data, the UE mobility for these users, and I will send a list of gypsy or MS-SISDN that identifies each UE's number in the 5G network. And using that, the NEF would process the informations and then send me back the location of each UE that I'm requesting, if it's a group of UEs or for a single user. And the problem is that only the access tokens and the security credentials are checked at the NEF level by the mobile operator. In the security specifications by 3GPP, it's stated that there should be restrictions on what a third party can have access to from the core network, from the capabilities, and for privacy concerns at the UE side. But then in the design and in the specs, those are follows, but then what about the implementation? Now we can see that in the actual content of the API from the 5G Open API, there are fields that are not mandatory, that are not required. So just by sending an analytic event and saying, for example, I need the UE mobility and I send the UE's gypsy, I will get back, if I'm fully authenticated from the mobile operator, I can get the data analytics from the UE, its location information, or any other type of analytics that I would request. And the problem also in this section is that there are this concern about the abuse of legitimate service providers. What if a trusted service provider abuses its access to the core network and then requests information from many UEs, from all UEs, possibly just by authenticating itself? And this is the privacy concern that arises in the API design, the implementation, that should be double-checked. So the idea would be at the NEF level to have kind of filterings and say, okay, even though this service provider is authenticated by the network, what should we put as a restriction on UEs that it cannot access? When you have, or when you would like to access the location information, in this case of one UE, there are more steps to go through before having that. So, and then restricting the users that one service provider can do requests on. And also to keep on memory at the NEF level that these service providers can access these UEs information and not all UEs information. In theory, it's done with the specifications, it's done also with the design, but then in the implementation, it's not. There are a lot of gaps between the specs and the practical implementation of those APIs. After identifying the gaps between the 3GPP specifications and the actual API implementation, we had to go through a practical, real-life attack scenario of the location tracking. And we used the 5G system at Aalto University to make it possible to see what's happening when a user enters the network or the cell ID, the coverage area of the 5G system, and how can one third party get access to those informations just by sending its authentication credentials and then the IMSI that it needs, the IMSI of the user, and then periodically gets back the location information and tracks the UE actually inside the coverage area of the 5G system.